Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of one-variable equations. This is standard 8.8C in the great state of Texas, and we are using item number 7 of the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have two different aquariums. They contain certain gallons of water, and then they're being filled at a different rate there. So after how many minutes will both aquariums contain the same amount of water? All right, so we need to kind of write our own equation here, but since we're dealing with the same amount of water, we know that we're dealing with an equation rather than inequality. And so really, in essence, we are looking for A1 to equal A2. So that's what I'm getting so far. And so what we need to do is we need to substitute what we know about A1 and A2. So aquarium 1 contains 4.6 gallons. All right, so that's going to be our constant. That's not increasing or decreasing at a certain rate. That's just what you're starting with, 4.6. And then we're going to begin filling at a rate of 1.2. So when you're filling, we're going to add. We're adding to something when we're filling. So I'm going to do 1.2 per minute. They don't give us what it's going to equal, so let's just call it M. So 1.2 gallons per minute. So I'm going to multiply those two. So there's my basic statement there. 4.6 plus 1.2 M. Let's see what A2 has. Wow, 54.6. That's a lot more. How are those two going to be equal? Oh, look at this. Draining. So we have to know these two words, that they're giving us opposite operations. So when I'm draining something, I'm taking away, I'm letting something out. So that's how they're going to be equal. 0.8 gallons per minute. All right, so if we don't set this up with one of them being plus 1.2 M, one of them being a minus 0.8 M, we're going to be kind of frustrated. So that's our basic equation. So now we need to solve for M. So we need to keep a balanced equation, which means what we need to do is whatever we do on one side, we have to do on the other side. And I want to first get my variables together. I need to get all my M's on the same side. And I want to end with the M's being positive if possible. If they end up being negative, it's a pain because you got to end up with a negative M and you got to multiply by -1 and you have to take an extra step. So if I think inverse operations, watch this. If I add 0.8 M, it's going to cancel itself out. Negative 0.8 plus 0.8, right? That's just going to make 0. So to keep it balanced, I have to add 0.8 M to both sides. If you do that, you're still good. It's a balanced equation. Oh, that's going to make it nice. Look at that. 1.2 plus 0.8 makes it just 2. 2.0. I'm just going to drop the 0.0. 2M. That's a lot better than a decimal. So I've got 4.6 plus 2M equals 54.6. I don't need that plus 0 because we cancel that out. Now I need to isolate this variable by getting rid of that 4.6. So that's a positive, which means we're going to need to subtract to get rid of it. Minus 4.6. That zeroes out. So I get 2M equals, look at that, 54.6 minus 4.6. We did all that work and it's 2M equals 50. All right, so we're almost there. It's 2 times M. So we just need to divide both sides by 2. So 2 divided by 2 leaves you with 1. So that's just M equals 50 over 2. But we do all that. We got decimals and everything. And it's just 25. So M is going to equal 25. In 25 minutes, you have the exact same amount of water in aquarium 1 and aquarium 2. So there is our answer, C.